Assalamualaikum warahmatullahi wabarakatuh. We are from Group 11 and this is our project of Chemical Engineering Thermodynamics about flash column for separation of acetone and chloroform mixture. This is our group member and consists of 5 people including me, Jauhar, Anissa, Alif, Wafa and Rabiatul.
The title of the project is Flash Column for Separation for a Mixture, which consists of acetones and chloroform. Then we construct 3 problem statements, which is 1. Design a flash for separation mixture of acetones and chloroform. Second, flash calculation of moles of liquids, moles of vapor, liquids phase mole fraction, and vapor phase mole fraction. And lastly, we plot graph of TXY and PXY and XY graph from the flash column. Take 3 assumptions condition, which is mole fractions 0.75 for acetone and 0.25 mole chloroform. The pressure 130 kilopascal and the temperature is 65 degrees Celsius.
So for the assumption, first the mixture is an ideal solution and 100% separation. Next, the basis of this process is 100 mole per hour of feed is fed into the flash column, and the last one is steady state operation.
List out the reference from table B1 for the calculations, which is molar mass gram per mole, eccentric factor, critical temperature in Kelvin, critical pressure in bar, compressible factor, and critical volume in centimeter cube over mole. Lastly, normal boiling point in Kelvin.
From table B2, which is we must find the saturated pressure by using the Acetone equation, which is component per acetone A is 14.3145 and chloroform is 13.7324. Next, B for acetone is 2756.22 and chloroform is 2548.74, and the last one is C, acetone is 228.06 and chloroform is 218.552. After we find the value from the table B2, which is Acetone equation, we use saturated pressure formula, which is P set KPA equal to exponent bracket A minus B over T Celsius plus C. So we got the answer for acetone is 135.5760 kPa, and the chloroform we got the answer is 114.8681 kPa.
Alright, next is to calculate the bubble pressure and dew pressure. So to calculate the bubble pressure, we assume Z1 is equal to X1. So P bubbles is equal to X1 times P1 set plus X2 times P2 set. So here we got 130.399 kPa. For dew pressure calculation, we assume Z1 is equal to Y1. So P dew is equal to 1 over Y1 over P1 set plus Y2 over P2 set. So from our calculation, we got 129.7292 kPa. Since the total pressure lies between the bubble pressure and dew pressure, so the system is in two-phase region, so the flash calculator is possible. So first, we have to calculate the value of K. Here, we calculate K1 first, which is by using P1 set over P. We got 1.0429, and for K2, we got 0.8836.
Now for the liquid and vapor mole fraction, which is X for liquid and Y for vapor. We will using rearrange Ross's law. For acetone, the formula is X1 equal to P minus P2 set over P1 set minus P2 set. The answer we will get is 0.7307 mole of acetone. For chloroform, we will use simple calculation, which is X2 equal to 1 minus X1, and we will get 0.2693 mole of chloroform. For vapor mole fraction of acetone and chloroform, we will apply formula Y1 equal to X1 times K1 to get the value of acetone. The value of acetone, which is Y1, is 0.7822 mole of acetone. And for the chloroform, the formula will be Y2 equal to 1 minus Y1. So the value of Y2 will be 0.12178 mole of chloroform.
Next, we must find the mole of vapor and mole of liquid. For the vapor, we use the formula 1 equal to sum of ZiKi over 1 plus V bracket Ki minus 1 and got the answer 0.6158 mole. And for liquid, we use the formula 1 minus V and got the answer 0.3842 mole.
This is the TXY graph. The reason why we do the TXY graph so that we can find a few information from it. So one of the information that we can find is the phase equilibrium in terms of liquid vapor equilibrium, dew point and bubble point. Also, we can also find the mixture composition and also we can see the separation process. One of the application of the TXY graph is actually we can use it in distillation and flash column so that we can design and find the operating condition. This is the XY graph. From we can see at the y-axis is y1, and from x1 is at the x-axis. So this show the x and y mole fraction. So from all the calculation that we done, we can find the design and find the mole fraction for top stream vapor and also the bottom stream that is liquid for in the flash column. So in our condition, initial condition is the temperature is at 75 degree. So by using the calculation from before, we can find find the solution, and the answer we will get at the top stream we will have total flow rate is 66.67, and also at the bottom stream we can get 33.33 mole per hour in the basis of 100 mole per hour.